Hello Year 10. Today we are going to be multiplying and dividing surds, but before we do that, let's review how to add and subtract surds. In question 1, we have 3 root 8 minus square root of 18. If you want to collect up surds by adding and subtracting them, they need to be like surds, and square root of 8 is not the same as a square root of 18. However, if I simplify those surds, I may be able to make them the same. To simplify the square root of 8, I want to find a perfect square that I can divide 8 by. 8 can be broken into 4 times 2. So I make it root 4 times root 2. Then I want to do the same thing with the 18. 18 could be broken into 9 times 2. Then to simplify, I'm going to square root the perfect square numbers. So the square root of 4 is 2. I multiply the 2 with the 3 that's already there to get 6 root 2. Then minus, square root of 9 is 3, so it'll be 3 root 2. Now they have become like surds. They are both square root of 2 terms. So we collect the numbers in front. 6 take away 3 is 3 root 2. Okay, going on to question 2, we have some fractions. To collect up our fractions, we are going to need to get a common denominator. The smallest common denominator that you could make with 10 and 15 is 30. You could go all the way to 150 if you just times those numbers together, but that would mean that there would be a lot of simplifying down that you would need to do, and that might be a little bit tricky with all the surds that are going to be floating around. So 30 is the better choice. The first fraction here, to get 30 on the bottom, you would need to times by 3. So we times the top by 3, which is 9 root 3. Then the second fraction was a 15 on the bottom, so that means I have to times that by 2. Timesing the top by 2, we will get negative 16 root 3. Okay, now on the top of that fraction, we have like surds. 9 take away 16 is negative 7 root 3, and that will be all over 30. Okay, so time for new work. Multiplying and dividing surds. To multiply surds, you multiply numbers with numbers and surds with surds. So that means that the things that are in front of the surd, so in this case the A and the C, they will multiply together and they will go out the front of the surd in the answer. Whereas the things that are underneath, which is the B and the D, you'll multiply those together and they will go underneath the surd. Next dot point says, be aware of the following rule. The square root of A, all squared, becomes A. That's because a square and a square root undo each other. And so we just get them cancelling out and we get A as the answer. That can also be written as square root of A squared. So again, the square and the square root will cancel out and you just get A. So both of those versions are effectively doing the same thing. To divide fractions, if you have one fraction with a surd with a fraction on the top and a fraction on the bottom, you can turn that into one big square root sign over the fraction, and then you could simplify the fraction down. Often we do this formula in reverse. We start with one big surd and we break them into two smaller ones so that we can simplify the individual numbers down. In this section, we are also going to be expanding brackets. So that means that we're going to also be revising the FOIL method, which means you do first with first, which is A times C. Then you do A times D. Then you move into B times C, that's your inside, and last is B times D to get the last one. So that's how we're going to expand those, but obviously it will involve surds. Okay, so here's our questions. Question number 1. Simplify square root of 3 times square root of 5. I'm multiplying a surd with another surd, so all I do is multiply the numbers underneath. 3 times 5 is 15, so it's square root of 15. Part B, square root of 5 times square root of 5. Now, if I did it the same as the last question, I would times the numbers underneath, which would be square root of 25. However, this is a special case because the square root of 25 is 5. So a shortcut is, if you are timesing a surd by itself, it's the same as having square root of 5 all squared, and the square root sign will disappear and it will just be equal to the 5. Part C, 2 root 5 times 3 root 2. We have numbers out the front, which we'll multiply together to get 6. And then we have numbers underneath the surds, which we multiply together to get 10. So it's 6 root 10. D will be very similar. The numbers at the front we will multiply together. Minus 3 times 7 is negative 21. Then the numbers underneath we multiply together. 3 times 8 is 24. This time though, 24 is a surd that can be simplified. And if the question says simplify, we should always give the most simplified answer that we can. So we're looking for a perfect square number that goes into 24. And it is 4 that we can use. It is 4 times 6 that makes 24. Square root of 4 is 2. We times the 2 with the negative 21 and we get negative 42 root 6. On to the next page, question 2. We are dividing surds. Remember that fractions mean divide. So if I have a surd over another surd, I can change that into one big square root sign with the fraction underneath, 20 over 2. And then I can divide those numbers. 20 divided by 2 is 10, so it just makes square root of 10. That does not work for question B when the top is a surd and the bottom is not. Okay, I can only do that when they're both surds on the top and the bottom. So for question B, my only option is to try to simplify the square root of 20. The perfect square number that I can use is 4 again. It is 4 times 5. That makes 20, and all of that will be over the 2. The square root of 4 is 2, so it's 2 root 5 over 2, and then the 2's will cancel out so that the answer is just root 5. Part C. I have a surd on the top and a surd on the bottom, so I'm going to make that into one big square root sign with 6 over 12. The numbers at the front, I'm going to keep them at the front. I've got 16 over negative 8. Okay, so now I'm going to divide each of those separately. 16 divided by negative 8 is negative 2. So a whole number, negative 2, like that. 6 over 12 underneath the square root sign makes a 1 over 2. If you split that apart again, you would have minus 2 square root of 1 over square root of 2 on the bottom. A square root of 1, this square root of 1 on the top, that's just equal to 1. So if you times 1 with the minus 2, your answer would be minus 2 over root 2. Question D, minus square root of 30 divided by square root of 10. Even though it's written as a divide sign there, we know that's the same as our fraction, so we could turn that into one big square root sign with the minus sign I would leave out the front, and we'd have the 30 over 10 going underneath. 30 divided by 10 is 3, so it would be negative root 3. Part E, minus 2 root 5 all squared. When something is squared, that means you times it by itself, so it's minus 2 root 5 times minus 2 root 5. Timesing that together, minus 2 times minus 2 is a positive 4. And the square root of 5 times square root of 5, that's a special one because it's times by itself. That becomes the whole number 5. 4 times 5 is 20. Now you may have been able to skip straight from there to that line by squaring the minus 2, so minus 2 times minus 2 makes the 4. Square root of 5 times square root of 5 makes the 5, and then you get straight to your 20 from there. Question 3, we're expanding our brackets. The first one is just a distributive law where we have one thing out the front and we want to times it into each thing inside the bracket. So 3 times root 3. One's a surd and one is not a surd. So when that happens, we just have to put them next to each other. That's 3 root 3. But root 3 times root 5, when they're both surds, we multiply the numbers underneath. 3 times 5 is 15. And that's it. B is similar, so let's do this one. 2 root 5 times root 5. The 2 is the whole number out the front. Root 5 times root 5, the square roots disappear to just make 5. Then minus 2 root 5 times minus root 3 is minus 6, and root 5 times root 6 is root 30. 2 times 5 is 10, so I'm just tidying that up to be 10 minus 6 root 30. Part C, we now have 2 sets of brackets, which mean that I need to do a full FOIL expansion. So F in FOIL stands for first. We do the first thing in each bracket times together. So the 3 times 5 is 15, root 2 times root 2 is 2. Then O stands for outside, so the 2 outside things in the bracket. We do 3 times 7 is a 21, and then we have a root 2. I stands for inside, so minus 2 times 5 is negative 10, root 2. And L stands for last, minus 2 times 7 is negative 14. Okay, the terms that will go together are 30, so we have 30 here, take away 14, that makes 16. And then we have some like surds. 21 take away 10 would be a positive 11 root 2. Part D, if we have a bracket with 2 terms in it all squared, you could do that by writing the bracket again next to it and expanding out using FOIL. But we have been practicing in algebra using the short method, so let's see if we can do the short method with our surds here. The short method says that we times the first term by itself. So 3 times 3 is 9, root 2 times root 2 is 2. Then we times the 2 things together and double it. So 3 times 2 is 6. Doubling that will make 12, and 2 times 7 is 14. Then you do the last one times by itself. So 2 times 2 is 4. 7 times root 7 is just 7. The 9 times 2 makes 18. 18 plus 28 makes 46 plus 12 root 14. Question E. This is a double set of bracket, but even more special than that, it is a difference of 2 squares because the brackets are the same, but one has a plus and one has the minus. That means the middle 2 terms of your FOIL expansion will cancel out. So the short method to expand this is to do first with first. 2 times 2 is 4. And then do last with last. Minus root 3 times root 3 is negative 3. 4 minus 3 is 1. Okay, so they're all your surd skills for today, but let's see a couple more challenging ones on the next page. Question 4. Find the length of the diagonal of a square that has an area of 18 centimetres squared. So here is my square. It has an area of 18 centimetres squared. And I want to try and find out the length of the diagonal. Let's draw that going across there. Now, squares are nifty things. They have right angles in the corners, and we usually use L in our formula for area, for the side length. So the formula I'm referring to is A equals L squared for the area of a square. The area I am given is 18, so it's 18 equals L squared. And what I'm doing is I'm working out the length of the side of the square, which means then I'll be able to work on that diagonal. I have to do 2 steps here. To get the L by itself, I'm going to square root the 18. And that is a surd that I could simplify, but I'm not going to simplify yet because I still have more to do, and I'll save the simplifying for the end if there is any. So if the lengths of my square now are square root of 18 here, and it would be square root of 18 there, if I want to find the diagonal, I'm going to use my right angle triangle and do Pythagoras' theorem to find the hypotenuse. So the hypotenuse formula is square root of a squared plus b squared. My sides of my triangle here are square root of 18 squared and another square root of 18 squared. When you square a square root, then that just gets rid of it, and you have 18 plus 18, which makes 36. You could type it in your calculator if you want to double check that. The square root of 36 is a nice whole number. It is 6. So the length of the diagonal of that square would be 6 centimetres. Question 5, we want to fully expand and simplify. We have a negative 10 root 3 sitting out the front. What we need to expand is this perfect square here. We have a minus sign, which is what makes this a little bit tricky, because that minus will have to expand into what I'm about to expand. So I'm going to use brackets. So minus sign, bracket, and now let's use our short method. 2 root 3 times 2 root 3. 2 times 2 is 4. Root 3 times root 3 is 3. Then we want to do the first term times the second term and double it. So 2 times 5 is negative 10, and then we double it to make negative 20 root 3. Then, last with last, minus 5 times minus 5 makes a plus 25. Close bracket. Okay, then let's go through again and expand the minus into that bracket. So we have negative 10 root 3. It's going to be minus 12. I'm just going to 4 times 3 is 12. Bringing the minus in here, we get a plus 20 root 3. And then bringing the minus in, we'll get a negative 25. So for like terms, we have a negative 10 root 3 plus 20 root 3. That would be 10 root 3. And minus 12 minus another 25 is negative 37. All right, that is it. Time to do exercise 4C.